All right, we finished off yesterday. I assigned you guys to do 3 and 4 in the workbook. We haven't gone over them yet. Sione, you're raising your hand because you want to say the answer? Okay.
Can I do 4?
So, sure. Well, 3 then. 3. There are 2 things we need to notice. Only 2 things that we need to notice. What's the first thing we need to notice about this compared to the standard cubic function? It's flipped, so it's reflected, right? It's reflected, which means we're going to put what in front of our function? A negative sign. And then what's the second thing we need to notice? Yeah, the center point. What's the new center? 0, 2. All right, so let's go ahead and do it. So y equals negative x minus 0 cubed plus 2. And a bunch of you yesterday, I recall, said, wouldn't that just be y equals negative x cubed plus 2? And absolutely it would. Because the minus 0 doesn't mean anything. Minus 0 doesn't mean anything. Yeah, either way, if you put, I wouldn't mark you down for y equals negative x minus 0 cubed plus 2. Those are both correct answers. Anything else about number 3? All righty. Michael Takis, how come we don't have our workbook out? Riley, do you? You do? Okay. All right, number 4, Sione. Oh, go ahead then, Elias. The center is? Right, so there's my HK. 3, 1 is my center. And then instead of going to the right one, up 1, and to the left one, down 1, right, we went right 1. No, we didn't. We went right a half, up 1. And we went left a half, down 1. Okay? So since my left and right is what's been affected, what value do I have? What kind of value do I have? What variable? You just going to go through the alphabet? B. We have a B value. B are horizontal compressions or stretches. B's are horizontal compressions or stretches. So we've been horizontally compressed by a half. We've been horizontally compressed by a half. Right? So what is my B value then? No, my B value is 2. Because when you put it in the equation, you're going to flip it. When you're going to put it in the equation, we're going to flip it. So we get y equals. It hasn't been reflected, so we're simply going to have 2 x minus h, which is 3, cubed plus 1. And, huh? No, you don't have to put 2 over 1. Yes? Oh no, my battery. You guys might not get verbal notes here. It's going out. All right? Yeah, I did a while ago. So when that stops blinking, all right, so you're going to have to keep, no, I don't want, that's weird. I don't want you to keep looking at it from where I have it clipped. So, all right. Yeah. Huh? All right, guys, 5 and 6, super easy. Let's get those done. I've actually, what's funny is I have an entire pack of batteries in my trunk. I just need one person. I'll send one of the people I've had for years here. So, like, Sione or Elias, you guys can rock, paper, scissors over it. Oh. All right. You know my car? Yeah? All right. Yeah, I'd never lock my car. Just go in the trunk. Yeah. I don't lock my car. So, And now everybody who watches this video knows, guys, I don't lock my car. Yes, yeah, just it's in the trunk, all right? All right. Huh? I don't go that far, but you know. I don't know what you guys are going to take from I got like that stack of napkins in the glove box if you got a like runny nose. Come on. Okay? Yeah, right. I don't know. My kids will like leave trash in there every once in a while. No, they don't. I'd murder them. So, I don't keep much in my car. That's all there is to it. Okay. So, this thing eats the batteries. I'm going to go through like 2 a week. That's expensive. So, well, no, I bought like a 20-pack from Stater Brothers for 11 bucks, so I'll be okay for a little while. But still, 11 bucks. All right, guys. Guys, this is super basic, super basic. F of x is x cubed is reflected across the x-axis. So what am I going to slap in front of it? A negative. Negative. Then it's translated 11 up and 7 left. I care about the 7 left first. So what's 7 left going to look like? X plus 7. What's 11 up going to look like? Done. Number 5 is done. That's it. Natalia. Okay. With that in mind, let's do number 6. Stretch vertically by a factor of 6. What am I going to do? 6 on the outside. Then I'm 9 right. X minus 9. It's a cubic function. And then 3 down. And I'm done. Yay, we're doing the homework. Oh, wait. Why isn't what? What are you talking about? It's always been there. Yeah. Open your eyes, Schinker. Jeez. No, I said Schnicker. You can play it back. And if I didn't, oops. It was a little unemphasized, de-emphasized in it. Yeah. Yeah. No. I'm not here to entertain you. Okay, guys. Homework. So you're going to have to write it down, Kelsey Descartes. All right. Yeah. Okay, so moving on from this, part 1 says graph our cubic function. We already know our cubic function goes through 0, 0, 1, 1, 2, 8. Negative 1, negative 1, negative 2, negative 8. What's 2 times 2 times 2? 8. So cubic function goes through 0, 0, 1, 1, 2, 8. No. Don't cry, Kaylee. It'll be okay. Seth, that's not you. Alrighty, guys. So here's our cubic. That's just number 1, not even part A. It says graph the parent function f of x equals x cubed. Done. Now use this graph to answer each question. I wanted especially to do number 1 even before I got to the point where I could do more with you guys because we're doing a half a period devoted to homework today. I wanted to get number 1 done anyways because there are a lot of throwback questions that we should not ever forget. So the first thing is what is the domain and range? So yes, there are an f and a g as well. So what is the domain and range of this function? Can somebody raise their hand and remind me what domain is? Michael. How far goes left and right, right? It's going to be, and somebody else up here are my x values. So how far it goes left? So how far does this function go left and right? Negative infinity to infinity. Okay? The domain of this function is from negative infinity to infinity. Because it goes left and right forever. I can cube anything. I can cube negative a billion. I can cube positive 2,794.69. Okay? I can cube anything. Okay? When I do that, what does the range end up being? Which is negative infinity to infinity. It goes up and down forever as well. It goes up and down forever as well. What is the end behavior? Somebody raise their hand and tell me, what does end behavior always start like when I'm answering that? Destiny. As x approaches negative infinity, y approaches, and then we answer. Also, as x approaches positive infinity, f of x approaches. This is every end behavior ever. Kalani. As x approaches negative infinity, what does f of x approach? As the function moves to the left, put a dot. I want you to go like this with your finger and put it on that graph somewhere. No, on mine. Do it, there you go. So you can see it. If you line it up, right, your eyeball's seeing your fingertip in the graph. All right? Now, I want you to move your finger left along the graph. Don't let it leave the graph. Okay? Move it left along it. Which way does it go? Huh? What direction? If you put your finger on the graph somewhere, and then you start moving it, your finger. All right? I'm going to try to make it move left. Am I still on the graph? No. All right? I need to stay on the graph. So I'm going to start moving my finger on it, going left. Which way am I going? Down. Going to negative infinity. There we go. As I go right, it goes up. Throwback questions. Big eyes.
Wait a minute.
No.
I thought it was.
Wait a minute. Something wrong here. Hold on a second.
No.
Something's fishy. Hold up. Give me a second.
I give up.
What's going on?
Okay, I thought that it was negative, or as it approaches negative infinity, the other one approaches positive.
No.
Okay.
It changes depending on what function we're looking at.
Okay.
On this one, as I go to the left, it goes down.
Now you know.
Okay. Identify the graph's x and y intercepts. Where does this cross the x-axis? 0. Where does it cross the y-axis? 0. Yeah. Whatever laziness you need to employ. Identify the intervals. Identify the intervals where the function. Identify the intervals where the function is positive. I'll give you a hint. Now, first of all, when we're talking about intervals, we're always talking about x values. After what x value is the function positive? It's positive right here, folks. Where is that? Somebody raise their hand and tell me. What interval? The function, I'll even start your English sentence off. The function is positive when?
0?
That sentence doesn't make sense.
When it's higher than 0?
When what's higher than 0? You said it's higher than 0. I have subject antecedent disagreement. You've given me a pronoun, and I don't have something to reference back to. Yes? The interval, no, the interval is defining it. When x is greater than 0. Okay? Then you got to, yep, Holly said it louder. Okay. The function is positive when x is greater than 0. Once I pass 0, boink, at that point, I'm above. Did you like that noise?
Do it again.
When I pass 0, boink, I'm greater than 0. Okay. When am I negative? Dimitri? When x is less than 0. Those are my two intervals. I'm defining the location of x when my function is positive or negative. Oh, now third period only got this one. Third period took a little bit to get to the correct answer on the first half, and they didn't get the second half. It was harder for them to get that one. So let me get Michael, maybe. Michael, when is that function increasing? So pretend you're just a little dot on that, and you're running on that function. When are you going uphill? Yeah. Always. So give me an interval for that. From negative infinity to infinity. It's always increasing. If he's a little dot on this thing, he's always going uphill. At some point, life gets a little easier for him right here, but then it goes back to sucking after that. Okay? All right, so I'm going to stay on Michael Takis with his brilliant answer. And I'm going to see, now, the first answer out of third period was not the correct answer for when is it increasing. And it definitely, the correct answer was not their first answer when it was decreasing. Now, Michael has already said the correct answer, and when is it increasing? It is increasing from negative infinity to infinity, though he used a much better phrase, even though this is the mathematically appropriate phrase, negative infinity to infinity. He said a much better phrase to answer, when is it decreasing, Michael? And you said the same wrong answer third period said. He said from infinity to negative infinity. Okay, when is it decreasing? Michael, what was the first thing you said? I said, when is it increasing? What was your first phrase? So when is it decreasing? Never. I fed you guys a little bit more because I'm trying to get you guys a little further along. If you want to take it as that, Holly. Yeah. Because of the fact that, Raymond, we're always going from left to right. So from left to right, it's never going downhill. Now, if we had this kind of function, Raymond, if we had this kind of function, if our cubic looked like that, we'd be increasing from negative infinity to wherever this x value is here. And we'd be increasing from this other x value to here, which is infinity. But when am I decreasing? I'm decreasing from here to here. Right. Always reading it from left to right. Now, third period had the great question of, do people in Japan, would they read it? Do they read their graphs from left to right? I don't know, but I think they do. They read text from right to left. I've never seen them do math, though. You know, even anime illustrators are afraid of writing math down. So, okay. Tell whether or not the function is even, odd, or neither. Explain why. Hand. What? Is the function even, odd, or neither, and explain why? Elias, your answer was wrong as you raised your hand. Just so you know, so that way I don't even... Okay. Raymond. It's not. It's odd. There's only one thing left. Alicia, why? Why is it odd? I can't hear you, Neff. The symmetry has origin symmetry. That's the answer to G, though. Okay. So really quick, why is it origin symmetry? If you guys don't recall, origin symmetry says that if I take this and do what? Flip it how? 180. You can't tell that I did it. Okay? So, prove it. Prove it.
In the video.
Dang it! Dang this evidence-based system!
You were so surprised.
Yes.
I wish I had Destiny's enthusiasm.
We all wish that we had Destiny's childlike wonder. Okay. Now, by all means, play that back, cut the auto, make that your ringtone, whatever you got to do. Okay? I want to hear that. I want to just hear that when somebody's phone goes off in class, like right before the holiday break, just childlike wonder. There you go.
What if we made like a remix?
Huh? Make the remix? What does that sound like?
Childlike wonder.
Okay. I'm glad that you were prepared to tell me what that sounded like right off the bat. You know what? I'm going to have to throw a hero point your way for that one, Kaya. I'm going to have to throw a hero point your way for that one. Okay. All right. Alicia, very simple answer because of the fact that my number one go-to would definitely be it has origin symmetry. That's what makes it odd, right? We can go by a couple of strict definitions. I hate the strict definition of odd, a function, which is if f of negative x, if you recall, equals negative f of x. So if I change x to negative, it changes the sign of everything within it. But the easy one, let's go with the shortcut, right? F of x equals x cubed. How many? There is only one exponent in this entire function. And it's 3, which is what kind of number? There we go. There we go. Okay? So, that is the only exponent, and it's odd. And that will make an odd function every time. "21 minutes. Let's see how far we can go. Braden's ready to push it. No, you're not ready. Braden's ready. That's right. Braden looked over at you when you said that. You weren't even looking at him. Braden was like, so. Okay. What's up?
Is the second question the same as this one?
No. G's been up there forever. All right, guys, 20 seconds. Riley. Shh, I can't hear Riley, guys. Nope. Oh, okay. No?
Hero point? 3 years.
All righty. All right, folks. Guys, I'm going to put 45 seconds. If you want to copy down the direction along with, please do so. Okay. 1 minute. Right. Seth. Writing. Yes.
Let's talk about how I ran into a pole.
Hmm? Elias. Because functions aren't capitalized unless they are the antiderivative. Yes, sir. What's funny over here, giggly crew? That would cause it. There you go. You're welcome. Another 10 seconds. Give you guys a time limit, and all of a sudden you all become Arnold Schwarzenegger. Like, okay. How it's related. Are you guys ready for the fastest questions ever? Yes. All right. Beatrice is going to start us off. Beatrice, number 2, what's going on? Beatrice, what's going on? I'm sure I just can't hear her. Number 2, describe what's going on to the function. So, what way did it move? Okay. All right. Elias can't control himself. Ladies, stop giggling. I've got 2 giggle crews today. Shh. Seth, don't join them. Michael, I can't come here. Put that phone away, Riley. What, really, guys? Really? Really? That was unnecessary. What? Oh my gosh, that's terrible. Okay. So, that was actually really terrible. Okay. That was gigantic. He had a swollen point on his forehead. It was like the size of the boil on from Timmy Turner's Friend. Okay. Yeah. Okay. It does. Put it away, Riley. Okay. Guys, you're cutting into your homework time. I'm not adding more to the video tonight, all right? So this one, as Beatrice said, she said it makes the vertex 4, 0, which is correct. It's not quite a vertex because of the fact it's a cubic function. It's kind of like the center of it more, right? But she makes the vertex 4, 0. But we want that in very easy terms. This is simply 4 to the right. That's the answer. Done. Okay. Number 3. Number 3. Destiny. No. No. Yes, vertically reflected would work. Vertically reflected. And there's something else. The negative made it vertically reflected. What does the 5 do? Vertically stretched by 5. Good job, Raymond. This is the one that we're going to write. That's a 3. This is the one that we're going to write the most on. All the rest are pretty short here. We'll jump back. Savannah, what's number 4 doing? Savannah, answer my question, then go back to writing. Up? No, up 2's right. Up 2. Okay. Colin, I'm going to give you the hard one. Number 5. What's going on with that one? It's inside. There's your hint. It will be. No. No. I don't mind. I gave you the hard one. Isaac? Horizontally. Horizontally. Compressed. By 1/3. Horizontally compressed by 1/3. I threw you a curveball, Colin. It was on purpose. I thought you got that one, but it's okay. You called in Isaac as a pinch hitter. All right, we're moving forward from that. Oh, Isabella, yep, doesn't matter. You did not break eye contact fast enough. Number 6, what are we doing? You are going left 1. Okay. I don't know, can you? I hate it when I say, like, when I do the sarcastic, I don't know, can you? And people are like, may you? What? No, that's not. No. May I? It's no. What do you? It's can I, may I, right? Ooh, nope. Vertically. Why is this one vertical? You tell me. It's on the outside. How do we know it's not on the outside? There are no parentheses. Riley, you've got number 8. The down 3. Good job. You had the right answer. Well, you don't got to get all like triggered by it. Come on now. Oh. Dmitry Yetsky. It is.
It's horizontally reflected.
Okay. Some of that's wrong. Horizontally reflected stands by itself. That didn't delete the way I wanted it to. That didn't delete the way I wanted it to. Okay, there we go. I'll just keep on going with it. Why not? Okay, the 2/3 is doing something. What's it doing? What's it doing? Stretched or expanded. By what? By 3/2. Thank you, Schnicker. Okay. When it's horizontal stuff, you got to do opposites. Horizontally reflected is that negative sign, and then the stretch by flip it 3/2. Okay. Okay. We still got 11 minutes. Let's keep it going. I think that's what I put in the notes. You tell me. 1 through 19. Let's go. Grind time. Beast mode. Big brain. Alpha mode. Not to be confused with Edna mode. Okay. Let's transfer these points, folks. This is a horizontal. We don't need to write this down, but we need to know, at least in our brains, this is a horizontal what? Stretch by 3. If I'm horizontally stretching it by 3, instead of going out 1, I'm going out 3. And still down 1 and up 1. No, you don't. No, you don't. Yes, it says to graph it. It says to map the points and graph it. I'll move in a minute. It's multiplying, correct, because it's a stretch. The pluses and minuses come from the H's and K's, the shift of the center. It's a horizontal stretch by 3. So my horizontal, which are my X values, are the ones that are multiplied. That's not always true, because if my HK changed, why are you so tired today, Bethany? I think you said that at the right audible level. For it to not, if you want, that's your call. Any questions here on number 10?
No, keep going.
People have fingers up and are asking to wait. Hey, that doesn't mean turn around to persecute them and make them feel judged. Dear Lord. It's like throwing people to the piranhas. What's up?
So, you know the original line that's on the graph?
Yep.
It's on like all of these? Is that like the basic one?
Yeah, that's the parent function, x cubed. That's the one I drew on question 1. Okay. Now what's fun is number 11. Yeah. Okay. This is a vertical compression by, no, not by 3. We don't change it if it's vertical. Vertical compression by 1/3. So now I'm still going out 1, but now I'm going up and down 1/3. I'm only going up and down 1/3. The vertical stuff, we go with it. So I'm still going out 1, but now I'm going up 1/3. I'm still going down 1. I'm still going left 1. I'm now going down 1/3. Well, here's what's fun about this one, we could say. You tell me what's fun about that.
It's more widely curved.
While I write this down, you guys can think about it. That's what happened. Why would I say this is neat? I don't have Raymond Ramirez today. I don't think I marked anybody absent.
Well, now he's here.
Destiny? That's Joseph Tomas Flores.
Isn't it the same as a horizontal stretch?
It was. The graph's identical to number 10, folks. The graph is identical to number 10. Number 10 was a horizontal stretch by 3. This is a vertical compression by a third. They look the same.
Oh, because it's the same thing.
Right? If I take, you know, silly putty, don't forget, if I take my little mound of silly putty and I stretch it vertically, what does the center of it look like? It gets skinnier. The more I stretch it this way, the skinnier it gets. So a vertical stretch is the same thing as a horizontal compression, right? And a horizontal compression, if I take that silly putty and squash it down, what happens? It oozes out the sides. So a vertical compression is the same thing as a horizontal stretch. Yeah, I have. All right, number 12.
Aren't you proud
Oh,
of me?
hey.
Hey, aren't you proud of me?
Okay. Okay. 12 and 13, even easier. Because there are no stretching or compressing, so this one's pretty quick and basic. It just moves the center. The center here is going to be 4, -3. And then I go right one, up one, left one, down one. And I make my curve. My center is -1, 2. And I make my curve. You can. You should. Can't seem to hit it. Okay. So here, 0, 0 became 4, -3. Okay. 1, 1 became 5, -2. -1, -1 became 3, -4. Here, 0, 0 became -1, 2. 1, 1 became 0, 3. And -1, -1 became -2, 1. Raymond's ham's cramping. Nobody asked you, Elias. Elias, he only says that because he does care. He's building up that wall, and you've just got to show him kindness in return, and it'll bring that wall down. You, that, you, so your sign of love is not insulting him? Yeah. Okay. Are we good?
Yep.
Okay. Okay. Oh. I think then. I think we're done then, folks. Yeah, we only have. Why isn't it going back a page? Oh, now my computer's just froze up. Ah! You guys can make that your ringtone too.